Okay, here's warm-up number 8. We've got a conditional statement, an if-then statement with a comma in the middle. That's what a conditional statement is. So this says, if it is Sunday, then it is the weekend. Okay. So I'm going to write first the converse of this. So actually, before I even get to the converse, the part that follows the if is called the hypothesis, and we'll often label that with a P. Okay. The part that follows the then is the conclusion, and we'll often use a lowercase q for that. Okay. So a conditional, here's how you can symbolize it. You've got a hypothesis that leads to a conclusion. Okay. With a converse, what you're going to do is switch the order of the hypothesis and conclusion. So if I went from P to Q, for my converse, I'm going to flip that around. I'm going to go from Q to P. Okay, so I'm just going to take the parts that I underlined and swap them with each other. Okay, so I'm going to write if it is the weekend, then it is Sunday. I'm not going to worry about if this is true or not. I'm just taking the parts and rearranging them. If you're asked about the truth of that statement, then we can talk about that, but we're not here. It just says write the converse. Here's the converse. Okay. If it is the weekend, then it is Sunday. Okay. All right, the inverse, we're going to leave the original parts in their original order, but we're going to take the negation of each part, okay? So what the little symbol for this, I'm going to go from the negation of P, the negation of my original hypothesis, that little squiggly is meant to represent the negation. I'm going to go from the negation of that original hypothesis to the negation of the original conclusion. A negation has the opposite truth value. So often, pretty much always, you can just put in the word not or isn't if it's an is part, okay? Or if it said it's not Sunday, then I just take out the word not. And most of the time it'll work like that. It's close to the opposite. It's not exactly the same as the opposite, but it has the opposite truth value. So let's say that today is Sunday. Okay, I don't know what day you're watching this, but let's say it actually is Sunday. So if that's a true statement, then it not being Sunday would have to be false. And not being Sunday, if I said it's any other day besides Sunday, that would be false, right? If it really is Sunday. Okay, so anyways, let's negate this first part. So I'm going to say if it is not Sunday. Doesn't matter if your wording is a little different. If you said it, if it isn't Sunday or something like that, it doesn't. That's fine as long as we get the basic idea. And then it isn't the weekend. Then it is not the weekend. Something like that. Again, I'm not worrying about the truth values here. I'm just writing the inverse. Okay. And then the third type is called a contrapositive. So here we switch the order. Here we negated both parts. With the contrapositive, we're going to do both of those things. We're going to switch the order and negate both parts. So that means I'm going from the negation of Q, the original conclusion, to the negation of the original hypothesis. So I'm going to take this part out front, but I'm going to negate it as well. So I'm going to say if it is not the weekend, then it is not Sunday. Again, if your wording's a little different, that's okay, but make sure you write it as an if-then statement with a comma in the middle, and you have those pieces in the right order. Okay. All right, and last up, we've got a biconditional that says, can a true biconditional be written? Okay, so in order to write a true biconditional, that's going to be an if and only if statement, by the way. For that to work, two things have to be true. The original and the converse have to both be true. So the original conditional has to be true, and the converse has to be true. Okay, so this isn't part of my answer, but I'm just explaining what I'm going to be thinking through. So I'm going to first look at the original conditional here. This says, if it is Sunday, then it is the weekend. Well, that's true, right? Sunday is on the weekend, so if it's Sunday, it is the weekend. This part is true, okay? And then if we look at the converse, if it is the weekend, then it is Sunday. Well, that's sometimes true, but not all the time, right? Because it could be the weekend, it could be Saturday. So it's not necessarily Sunday just because it's the weekend. So that means this statement is false. If it's false any of the time, it has to be true all of the time to be true. If you have any examples, counterexamples that show that it doesn't work, then the whole statement you can say is false. Okay, so my original is true here, but the converse is false. So that means that I can't write a true biconditional. So my answer is no, and you can explain this in many ways. I'm just going to say the converse is false. Or you could explain why the converse is false. You could say, well, because Saturday is on the weekend. Or if it's the weekend, it might be Saturday, something like that. Okay? All right. And that is it for today.